Hey, hey, hey! When I was choosing what to film for my science project, I saw an old tube of soap bubbles in the corner of my room. A great idea came to my mind. Soap bubbles! Bubbles fascinate both children and adults with their beautiful shapes and colors. Such simple ingredients create mesmerizing examples of both geometry and chemistry. What is a soap bubble made of? If you said soap, water, and air, you'd be 100% correct. A soap bubble is just air molecules trapped inside of soap and water molecules. However, there's more to bubble science than meets the eye, and it's quite fascinating. In my video, you will see the magic world of soap bubbles. Different shapes, different colors, different sizes. And I hope it will answer a lot of soap bubble related questions. What? Why? How? Vocabulary, you need to watch my video. Elasticity, the tendency of materials to return to their original shape after being deformed. Hydrophilic, attracted to water. Hydrophobic, repelled from water. Marangoni effect, when liquid flows away from regions of low surface tension to regions of high surface tension. Minimal surface shape, a shape that has least surface area for a given volume of air. Surface tension, the force between water molecules at the surface of the water. To collect the information I needed, I used a couple of websites. Thank you, Google. Knowledge and experience of my parents in photography and video editing. In addition, I spent hours on watching some professionally made soap bubble videos. It took me about 2 weeks to do research, plan, and do the shooting. With the help of my dad, I set up the scene for my video using lighting, softbox, camera, and a tripod. I had hundreds of takes from different equipment and different settings, so I had to do some editing. My mom taught me how to use Vegas Pro to combine, cut, split videos, add music and sound, work with text and effects. By the end of my project, I realized that I learned a lot. What is a soap bubble, how it forms, and what makes them so mesmerizing and colorful. But what is most important, now I have proven evidence that soap bubbles are a great way to spend some quality family time blowing bubbles, laughing, and sometimes competing. Thank you for watching. Soap bubbles, those delicate spheres of iridescence that float gently on the breeze, are a universal symbol of joy and wonder. They have a magical, ethereal quality that has captivated humans for centuries. Soap bubbles are beautiful, fun, and fascinating. But do you know what they are and how they work? What exactly fascinates children, adults, and even pets? A soap bubble is a spherical layer of soap film encapsulating air or gas. The film consists of a thin sheet of water sandwiched between two layers of soap molecules. One end of each soap molecule is hydrophilic or attracted to water. The other end, the hydrophobic end, crowds to the surface trying to avoid the water and sticks out away from the layer of water molecules. As a result, water molecules separate from each other. The increased distance between the water molecules causes a decrease in surface tension, enabling bubbles to form. Surface tension is the force between liquid molecules at the surface of the water. The water molecules cling to each other, which causes the surface to behave like an elastic sheet. Elastic substances tend to return to their original shape when they are stretched. Water doesn't make stable, free-floating bubbles all by itself. Adding soap decreases the surface tension so the water can stay stretched around the bubble. When you play with bubbles, you'll notice they come in predictable shapes. That's because deforming a bubble takes energy. The bubble tends to spring back to shape that's stretched as little as possible. The minimum surface. Floating around in the air, a bubble will become a sphere. Because the sphere has the least surface area for a given volume of air. Even as the bubble is blown up larger or is stretched in various ways, soap stabilizes bubbles by an action known as the Marangoni effect. In places where a bubble is stretched, the surface concentration of soap decreases, which causes the surface tension to increase. This area is an increased surface tension, springs back to its original form, and prevents the bubbles from stretching to the point of popping. The result is a spherical bubble with a uniform surface tension. When two or more soap bubbles meet, they merge their walls to reduce their surface area. The angle between the walls is always 120 degrees. If the bubbles are the same size, the wall between them is flat. If the bubbles are different sizes, the smaller bubble bulges into the larger one. When many bubbles meet, they form hexagonal cells. Bubbles are the subject of fascination for young children and legendary physicists alike. They're pretty to observe. They also offer intriguing lessons in fluid dynamics. Looking closely at the soap bubble, a shimmering, iridescent surface swelling with activity can be observed. These mesmerizing effects are due to the Marangoni effect. This phenomenon comes into play when there is a gradient of surface tension along the boundary between the liquid bubble and the gas filling it. This gradient means the tension is greater at some parts of the surface. As a result, molecules called surfactants, which reduce local surface tension, are tugged towards a region of higher surface tension. This in turn changes the surface tension gradient in the thickness of the film. So the surface flow creates the dizzying rainbows that make bubbles so amazing. The perfect soap film for bubbles comes from the perfect solution. Numerous variations of soap bubble solutions appear on the internet. Almost all recipes involve detergents and water. Unlike soaps, detergents don't contain a carboxylate group that reacts with calcium and magnesium ions found in hard water to produce a scum. Therefore, detergents are dependent on distilled water for bubble formation. Glycerin is often included as well. Bubbles eventually burst once the layer of water evaporates, but adding glycerin lengthens the lifespan of bubbles. Glycerin forms a weak hydrogen bonds with water, delaying the evaporation. Welcome to the magic world of soap bubbles.